The age of the universe enables us to not only understand where we came from, but potentially the fate of the universe, what will happen millions and billions of years from now.
If scientists confirm the value of the Hubble constant, the elusive figure that tells us just how fast the universe is expanding, it will tell us the age of the universe, and it will help us predict its end.
Measuring the Hubble constant is measuring the expansion rate today, right now. It's like checking your speedometer at one moment. But just because it's your speed now, it doesn't mean it was the same speed when you left your home or the same speed when you'll be on the freeway.
How the expansion changes over time will control the fate of the cosmos.
So depending on the Hubble constant, the universe could continue to expand, it could accelerate its expansion rate, or it could be decelerating.
At the moment, galaxies are racing apart. A continually expanding universe will cool down as it spreads out.
Another name for this eternal expansion is the Big Freeze, because as everything gets spread out, the density's lower, and there's no more opportunities for temperature differences. Everything just gets colder and colder and colder and colder, slowly, eternally approaching absolute zero.
The more matter is spread out, the less chance there is for star formation.
And so the universe's continued expansion means our night sky and every night sky in the universe will inevitably continue to get darker and darker and darker as things move further away and as stars die off.
Eventually, all the stars will go out, and there'll just be the leftovers, which we call the degenerates. Black holes, white dwarfs, rogue planets. It's gonna be a very, very sad place.
The last refuge of any matter at all will be black holes.
You've got a big black hole in the middle of each galaxy. Over trillions of years, everything in galaxies fall in. So finally you're left with big black holes over vast distances, separated almost universes away.
So getting towards the Big Freeze, black holes themselves start to evaporate. There won't even be black holes at the end of this accelerating universe.
All that's left is very, very low energy photons and a little bit of matter dispersed throughout the universe, and there's nothing left. That's it.
We call that the heat death of the universe. There's no longer any place that has more energy or more heat. It's all just thin, barely there photons.
It's fascinating scientifically, but from a human standpoint, not a lot of fun to think about.
But if the Hubble constant, the expansion rate of the universe, keeps increasing, then the end of the universe could be a lot scarier and come a lot sooner.
One possibility is that the expansion of the universe will accelerate and continue to accelerate forever, faster and faster and faster. And if that happens, we face a scenario that we call the Big Rip, where actually the whole of space essentially just gets ripped to shreds.
So the solar system is going to get ripped apart. Then the sun and the planets themselves will start to get ripped apart. And finally, it works its way down to atoms. And atoms gets ripped apart. And we're starting to see effects on space and time. Space is ripped apart, time comes to a stop.
So in this scenario, time and space have no meaning. If everything is infinitely far apart, then space doesn't really exist. It's sort of beyond our comprehension.
Working out the expansion rate will tell us which scenario we face. But for now, the lifespan of the universe is unknown. Maybe we need to investigate the other end of the timeline. But how can we get a fix on the age of the universe without understanding its origin?
As you go back in time towards the Big Bang, our knowledge of physics really goes out the window.
Temperatures off the scale, pressure off the scale. The way everything behaved is just so different that the rules we have now do not apply.
The biggest problem of all, what came just before the Big Bang? Einstein's general relativity predicts that all the matter and energy in the universe was concentrated down to a single point, a singularity.
The singularity is like the part of those old maps that says, "Here be dragons."
Singularities are a problem. We don't like them. This is where basically you have a finite amount of matter in the universe, but it's squeezed down into 0 volume, so it would be infinitely dense.
Infinite densities don't actually happen in nature. This is a sign that our math is breaking down. This is a sign that we need to replace that with a new understanding.
Many now believe Einstein was wrong. There was no singularity, begging the question, could the age of the universe be infinite? Scientists investigating the age of the universe are struggling to understand its origins. Could that be because there was no beginning? Could the universe be infinite?
Because we think we live and we die, we project that onto the universe, but that may not be the case.
The idea of an infinite universe is no more strange than the idea of a singularity. And in fact, throughout most of history, astronomers thought that the universe was probably infinite.
The foundation of our mathematical understanding of the universe, Einstein's general relativity, has a problem. It doesn't translate to the world of the very tiny, which is why its laws break down close to the Big Bang.
General relativity does a great job at describing things on scales that you and I are familiar with, and things like how planets move and how galaxies evolve, all the big stuff. Quantum mechanics, on the other hand, describes the world of the very small, the world of the atoms. The problem is that these two theories don't fit well together at all.
A new theory, known as loop quantum gravity, brings quantum theory and relativity together, and it makes a stunning prediction.
So one possibility is that the end of the universe could kind of match onto the beginning of a new universe and create a cycle of universes, one after the other.
Nicknamed the Big Bounce, it predicts a universe that stops expanding and switches into reverse.
And the idea here is that the universe can expand for a time, stop expanding, and then begin to contract again. And some have suggested that perhaps there's a cycle of expanding and compressing. It bounces back over again.
One of the appeals of the bouncing model is that it allows us to get beyond the singularity.
A bit like recycling on Earth. All the components get crushed down and then reused, giving the cosmos no beginning and no end.
If the universe is cyclic, does the age even have a meaning?
Age is a construct of humanity because we need to count time. But if the universe is infinite, maybe it doesn't matter in the big scheme of things.
A contracting and expanding universe messes with the concept of age. But the very idea of an expanding universe provides another cosmic curveball. It might not be alone. It might be just one ageless universe among many. It's an idea embedded in the math of the Big Bang.
The most popular theory we have in astrophysics for what put the bang into our Big Bang is inflation. This idea that there was a kind of dark energy on steroids that made our universe double over and over, not every 7 billion years, but every split second, creating out of almost nothing a Big Bang.
When the universe was just 100th of a billionth of a trillionth of a trillionth of a second old, it underwent a period of rapid expansion called inflation. It doubled in size at least 90 times, going from the size of a subatomic particle to that of a golf ball.
The problem with this inflation is, but it doesn't really stop. It just makes this ever bigger space and says that, yeah, well, okay, there was one region of space where this crazy doubling stopped and galaxies formed, and that's us. But there's this vast realm out there where inflation is still happening.
In the spots where inflation stops, parallel universes form.
This eternal inflation means that new universes are popping into existence all the time, but they're completely separated one from the other.
We may be living in a parallel or pocket universe.
In science, the holy grail is to observe what you predict. So what we need now is a prediction of an observation that is a consequence of the existence of the pocket universes.
And some cosmologists believe they have one.
There are clever ways that cosmologists have cooked up to detect the existence of pocket universes. Ever so rare, another pocket universe may collide into our universe and leave an imprint in the cosmic microwave background radiation.
But until such a scar is found, many scientists remain unconvinced.
Many of my colleagues hate parallel universes. They just don't like the idea that our universe is so big and most of it is off limits for us. If you are willing to be a bit more humble and accept that reality might be much, much bigger than we will ever see, then parallel universes feel pretty natural.
It's really interesting how everything in the universe is tied together. We can start with a simple question like, how old is the universe? And here we are questioning virtually everything about the universe.
Cosmology's century-long search for the age of the universe forces us to question our cosmological model, the nature of gravity, and even time itself.
The age of the universe does bring up sort of profound philosophical questions about how a universe can even start. How can you create something from nothing?
The vast majority of whatever the universe is eternally hidden to us. So we answer the questions, how big, how old? And those very answers show us that we don't even know if we've asked the right questions to begin with.